Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Last stream, it was Friday, I believe. We finished doing a to-do item on our list. I think we actually started it and finished it. We just wanted to turn off sorting for our debug system. I believe that was the last element of that thing on the to-do list, so I think we're on to a different sort of segment of stuff. We did this disable sorting for debug view so it isn't slow. So I think today we are going to be on our Z, finishing up our Z stuff, which we've wanted to do for a long time, but there's just a lot of things that we kept having to sort of push up against in order to really make sure that would work. And so I think now we should be able to kind of go over the final pass. We've kind of got most of it doing what it's supposed to do, and I think we even sort of did the thing where we have multiple like render targets for different like floor levels and stuff like that. So I think we've really done most of the stuff that we would need to do for Z handling. But now we just need the final piece of it, which is that it's kind of a two-part projection. And we want to make sure that that's actually working right. And so we kind of got to go just work with that a little bit and just get that into the sort of make that sort of a little bit more stable so that we know what's going on there. And along with that, I think we probably want to just kind of like do a one pass over the renderer now and just kind of look through it, make sure like I kind of got the screen, world, texture, coordinate stuff listed there. Kind of go through it and just make sure, like, okay, can we smooth any of this out? There's just a lot of junk in there at this point because it's kind of like a crude, a lot of different things that we've tried to do with it. You know, can we take a look at some of that and maybe simplify it a little bit more? What about sort of the performance of it? It's got some things in there right now that are kind of a little bit questionable in terms of how slow they would be and so on. You know, is there any of that stuff that we want to kind of work out? And I think that transitions nicely into particle systems because really these are sort of all, I think, kind of lumped together because there's nothing particularly special about particle systems. Particle systems are very, very simple. Usually the complicated part of particle systems is not writing the particle system code, which is pretty random and hackish and not particularly difficult. It's just, oh, I've got all these little points that I'm moving around that I'm doing simple physics on them, whatever. It's usually the rendering part that's complicated. Either because you just are trying to maximize the speed, the number of particles you can get, right? And you know this is something that can take really extreme forms. Like people nowadays will do particle systems entirely on the GPU, for example, to avoid round tripping from the CPU, so that you cut down on bandwidth, et cetera, et cetera. Right, so there's a fair number of things that are involved in the particles and stuff, but it's almost all on that sort of rendering side. The actual idea of like, oh, can I move some particles around? You know, I kind of covered that already on Handmade Hero, and it's really not super complicated. It usually ends up being kind of that second stage. How do I do enough of these? How do I, maybe light them properly? How do I do all that stuff? That's really where more of the sort of finesse lies. So in terms of looking at the particle systems, even though we have a fairly simplistic renderer on Handmade Hero, obviously, we would still have sort of some of those same concerns, right? Like we would want to kind of look and go, all right, how do we make sure that we can send enough particles down every frame? How can we sort of make sure that we certainly don't want to dump all of those particles into the sorting system, for example, as individual sprites, because that would really tank our performance if we wanted to scale up the number of particles to a larger number. So there's just kind of like stuff like that that's, I think going to be worth thinking about. And furthermore, we kind of have some other things we might want to look at in terms of particle systems. For example, maybe included in that are sort of some of the continuum dynamic stuff, like for example, if we wanted to have some low-lying fog or something like this, who knows, but something that was more of an implicit surfacey sort of a thing. So we kind of have a number of things like that, and those would all be about like how do we communicate those to the renderer. They're not really so much about any kind of complicated implementation in terms of like the theoretical aspect of it. It's mostly all just, all right, once we actually know what we're trying to simulate and what the code is here, how do we actually make sure that it's not a performance problem? How do we make sure that it dovetails nicely with the rest of the things we're rendering? All right. So I'm going to go ahead and jump right into looking at that Z stuff because I'm pretty sure we don't have any open issues at the moment that I am interested in looking at. I'm still waiting for someone to tell me Clang compatibility-wise if there are macros we can use that would help with the Clang compatibility, because I think that it's only our macros that are causing Clang to have grumpiness about them. So until then, that one's kind of on the back burner, and these two are not really... in fact, I don't know what this means. This is I guess we could say enhancement. So I guess I'll say that these are enhancements, let's say, right? Did that do? Yeah. And then this one is what is this? I don't know. This is compat, maybe. Can I can't. What? But no. But I want to apply a label. Well, that's not very good. Are we basically saying that I can't create my own labels? All right, well, I don't know. Doesn't matter. Anyway, point being, so these are enhancements, and so those are not really bugs that we have at the moment that we want to look into. But this guy is, and we're just waiting for someone with Clang to sort of give us that, and then we can close out that guy. But I think we're otherwise pretty much good to go here. And also, I would mention if in general, if people would please like not report non-bugs to the bug thing. Like, I get a lot of people who like report stuff that are just like they don't like the way something was coded, but that's not really a bug, right? So I mean, you can do those if you want to, but I'm just going to close them immediately as like this is not a bug. So this is really supposed to only be for stuff that we actually care about, that's an actual bug, meaning that it causes a bad behavior in the program, not you didn't like how I casted that pointer or something, because that is not a bug, that's a preference, if that makes sense. All right, so if we go to our render stuff here and take a look at it, you can kind of see our particularly unusual projection stuff here. It's not really what you might normally think of as projection code. It's a little bit odd, right? And that's fine because, you know, we are a 2D game and we have some kind of weird ways in which we project stuff. But if you'll notice, we have sort of already, even just at the start, because we had said how we wanted Z to work, we did not want there to be any sort of like dilation, X and Y dilation, as a result of Z within one floor level. You can see that we're still, even though we did all the work of like doing this whole like this thing with the fade in, right? Like that thing. We still sort of have this problem that we don't have those stairs lined up the way they're supposed to be, right? They are still going through a transform that makes them blow out, you know, makes them sort of scale and do what they're not supposed to do. And this is a problem for multiple reasons. One, it's not how the game is supposed to look, so that's a problem. We have to go fix that so that they don't have that happen. But two, it also breaks our sorting because our sort was designed to be kind of a fairly minimal, like we didn't do a very complicated sort criteria. So our sort criteria isn't really even set up to handle stuff that's skew like that. We just did a very simple YZ kind of thing. And so you can see that it gets the sort wrong as well. So it creates like problems for everybody, really. It's just not a good thing. So if we want to fix this, we need to start, you know, we may have to improve the sort criteria as well. That's a separate thing, obviously. Because we can always go make our sort criteria better than it currently is. But at the moment, we kind of have this problem where, okay, so those stairs need to stop doing that, right? They need to stop having that scale applied to them. And so in order to do that, you know, we could make all of that scaling go away if we wanted to, because if you take a look at how that's working here, you can kind of see that the way that we do our distance scaling here is we have like our distance to PZ, and you can see us doing our projection here where we take 1 over distance to PZ and we multiply it by sort of the standard camera transform that we talked about way back when. And that projected XY is what, you know, this distance to PZ part of that projected XY equation is going to give us that sort of XY dilation. And that is not actually what we want to have happen, right? Now, we could turn it off entirely if we wanted to, right? We could certainly say that instead of distance to pz actually including the z-coordinate that we're dealing with, we could turn it off entirely by saying, hey, distance to pz is just going to be equal to whatever distance above target is, right? And that's all it is. And if you look at what happens there, then we do have sort of what we wanted, which is everything flattened down, but we don't get the y part of things. So we kind of have like these mysterious things in here, which are sort of, you know, they're kind of totally rendered wrong because they don't actually sort of go up the way they're supposed to, but at least they don't do sort of that blowing out, right? So what we could do is say, well, we know we don't ever want the x to blow out there, you know, on a single floor. So if we wanted to, we could say, well, all right, so, you know, we don't want that. But when we go ahead and get this projected xy, when we come through here and we do this equation, instead of having the projected xy's x persist, we could overwrite the projected xy's x with the original x, right? Or similarly, with some sort of a distance to pz here that was fixed, right? So we could do something like this. Of course, I have to actually just get the x part of it, like so. And you can now see that we're sort of starting to get a little bit better. Oh, well, you know what? When I said x, I meant y. I just said we wanted the x to be the same. Oh, wait, no, but that's what I did want. Never mind. No, that's what I did want. Take it back. Okay, so anyway, you can see what's going on here, right? Now the x-coordinate is aligned properly, right? The x, these things are staying in the same place in x, and you can kind of see that as I kind of hop up these guys, it's all good, right? I can sort of get in there. And, you know, it looks like what it should look like. However, you can see that the right side of it is wrong. And the reason that the right side of it is wrong is because although we are now keeping the x position proper, we are not, when we return the scale value, we're returning a single scale value for x and y. And that scale value is going to make the thing change size, right? So although it's like aligned on the left side properly, it gets too big. Now, since we don't really want to do any perspective scaling, really all we should have to do here is instead of using the meters to pixels times the projected xyz, what we can do here is just make this be a fixed factor as well, right? Well, of course, fixed factor is probably, we need it to actually be a fixed factor. You know what I can do? Let me do it this way. So let's compute two of these. Let's compute first something that's more like unscaled xy, right? Something like that. So here we do the unscaled version, right? And so then what I could do is say projected xy.x equals unscaled xy.x. So now we are not doing any perspective transform on the x value. And then the scale, I do the same thing. Instead of using the projected xy, I'll use the unscaled xy. And then, in theory, we should be a little bit better. I missed something here. There we go. Okay. So now we have like an unscaled one and a scaled one. And now you can see that we've got something that's a little bit better. It's still there's still a couple things about it that we probably would want to fix. But you can kind of see that now we have things that are the right size. But if they are higher, they actually got sort of higher in y, okay? So that's good, and we're getting better, but we still have a problem, which is that when I hop up these guys, you can see what happens is we get a very unsatisfying result there on what happens to the level above us. And the reason for that is because that level above us, we do actually want to have that do all of the x, y, and the scaling and all that sort of stuff, right? And so there you can sort of finally see where we have this sort of nasty problem that we've got, which is that we want it to work this way inside a layer, but then when we get up, each individual layer that we get up, we then want to do the scaling as we sort of come up to that layer, right? So the layer itself should be scaled differently. So that's kind of tricky, right? And the reason that that's kind of tricky is because we don't really know exactly, we don't have a good sort of concept when we get into this part of the renderer. We don't really have a good concept of what those slices in Z will mean, right? We don't really know what those are. Now, we could enforce them to be something in particular, meaning we could just say that we're going to use some arbitrary set of Z values here and do it that way, but that's not a particularly satisfying, potentially, way to go about this, right? So, we're sort of left with this ugly problem of, do we have to do something a little bit more explicit when we're actually passing these things down? Do we need to send a slice index, and that slice index will give us some degree of, will go into the scaling in one way. It'll be the thing that allows sort of the actual scaling to occur. And then, we've got, in addition to that, we also have the sort of nominal Z, which is really just creating a Y displacement for our, orthographic look, right? And so there's probably a reason why very few games, if any games, have ever done something like this, because it's just kind of finicky. But it's not, it shouldn't be unachievable to want to do a slicey thing like that. We just have to come up with a relatively easy way of passing it down. Now, we do have some stuff at our disposal here, right? We do have the object transform, and the object transform itself obviously is passing a bunch of stuff here, and you can kind of see that inside the object transform, we do have like a chunk Z thing that's getting passed here. And that chunk Z is the piece of information that we kind of want for that additional scaling, right? That chunk Z would tell us exactly that piece of information. It would tell us how far this thing is in terms of slices, and all we would really need to know is how that chunk Z lines up with the Z of that we're looking at, right? And so if that chunk Z were in terms of like negative, positive, and so on, that might be useful. Now, I'm not sure where that's being set. It's been a while. So I kind of want to see what's going on in terms of this piece of information. I think... Yeah, so it kind of looks to me like this is mostly just being used, because that stuff isn't used anymore. This was mostly being used just for the sorting, right? You can see that that's going into the sprite bound there, and it's just being set to whichever layer we're on. And that's great. The problem with it is it's just an integer offset. So it doesn't really tell us all that much about how, it gives us a rough idea. Let me draw this out for you so you don't have to guess what I'm saying. Oh, I'm tired. Uh-oh. I think Milton is not happy. Okay. So there's a lot of ways we could do it. We could use that chunk C. However, what I'm thinking in my head is we want a continuous transform, obviously, and the thing that we're looking for here, right, is we're kind of looking for some way of having, if these are sort of our levels, right, and maybe this is where the hero is, he's kind of on this level, right? Oh, no, maybe there's the glove there, and it's not a very good handmade hero. Maybe it looks like this. Much better. Much better. So if this is the floor that the hero is standing on, and this is like, you know, one up from, and this is one down or whatever, then when we're talking about a z, essentially what we want to know is we want to know, first of all, what is its displacement off of its floor, right? So we're looking for this piece of information, because this piece of information right here, in fact, we can sort of talk about this as a separate thing. This right here, that is sort of an h. That's like the height off the ground, let's say. H is the orthographic portion, right? That's just going to displace us in y. And no matter how far you go up or down, if you're only within that floor, we're just displacing you in y. That's what we want to do. So then the other thing we want to know is what is its floor's displacement from the camera, right? So, you know, if the camera is looking right here, let's say at the time, then in addition to this h value, we also want to know this other value, which is effectively, let's say, our z value, right? And the z value is the perspective part, because however far that floor is off of the camera, that's how much the whole thing is going to get, you know, x, y transformed and scaled and all that stuff, right? So what we want to be able to know is where is the camera relative to the floor of this thing, whatever that is. And go back to our, let's see here, here it is. So we want to know that so that we can do our projected xy portion of things based on that piece of information. And then we also want to know what the just what the h value is, because the h value would also provide that sort of y dilation, which we could even do explicitly. We really don't need to do the distance above target focal length thing here, and in fact I think we don't want to, because we want that displacement to be constant no matter what's going on. So I think we would just want to apply it prior to the projected. So just do the constant first in here, and then apply the projection to it so that it'll scale properly along with everything else, if that makes sense. So really, I think all we need to do is perhaps know what the floor, know where the camera is, and then know where the floor height is for any individual object that we set. So that render transform kind of just wants to know the floor for this guy, what his floor value is, right? Or we could call that a z value, but it's what his floor value is. And then also that h value, which is going to be different. Now, we can still pass down absolute z values, right? So what we could do is we can pass down an absolute z value just fine for somebody, because if we're also passing down what the floor value is, we know that the relative h value, the h value would just be whatever that absolute z is, we would just subtract the z of the floor away from it, and that would give us the h value that we need, right? So we can still essentially do almost exactly the same interface to the renderer that we have been doing. Like I said, renderer, right? Renderer. Is that a random renderer? That's kind of like when people say dranks, right? Like, you know when Microsoft sent out that recruiting letter and said that they would be supplying, I think they used the phrase hella dranks, or maybe, no, you know what I think they said? I think they said just lots of dranks, or something like that. Yeah. Microsoft is just a party animal. They're just party animals. You don't understand. They've got all these dranks. You know what I'm saying? They just have all these dranks at Microsoft. Anyway, so if you don't know what I'm talking about, I'm sure someone on the chat can post a link to that ridiculous thing. I posted it on Twitter. It was ridiculous. It was crazy. Anyway, so we should be able to get that value pretty easily. And so all we should have to do here is when we set the chunk z, we could also just set what is the actual z value of the floor at that time. And then I think we would have all of the information that we actually needed for this process to work properly, right? Because if you look at how this transform works, if I get rid of the unscaled xy part of this, because I was just sort of doing that for explanation purposes, I don't actually need any of this stuff to do what it's doing. If you imagine that I just reset this back to how it was before, right? So this was, I believe, the way that we'd had it previously. Oh, sorry, I didn't mean to leave that sort of chunk Z test in there. If we take a look at what this was doing before, right, we're back to the old way. All I really need to do is say, well, okay, let's do exactly that same thing. Keep everything the way that it was going. Don't do anything different. It's just now, instead of using this PZ value, I'm just going to say, well, I need some new stuff here, right? I need a Z for the floor, right? I need whatever that value is. And then I need like a height or something. Height off floor. Right? Something like this. I could also say floor Z. Maybe that's a better way to say that, right? So I don't know exactly where I'm going to get those yet, but I do know, like I said before, if I want to, this P value that comes in, this PZ value that I get after I've done sort of my beginning transform stuff there, when I get that, I can easily subtract the floor Z to get the height off floor part that I wanted. And so really it's just the floor Z that's the thing that I need. Everything else would work fine. And then I'm also saying, okay, I'm not going to use any of this PZ value here. I'm just going to use the floor Z and the floor Z alone to determine how I'm going to do my perspective transform. All the rest of this stuff will work the same. The only thing that I now need to do is say that whatever my raw XY is, right, this raw XY here, whatever that raw XY is, and also, by the way, I don't really know why this isn't in there. No idea. Furthermore, I suppose this doesn't need to be in there. All of this stuff is kind of, let's try to clean this up so it's clear what's happening where. I don't know what offset Z is. I don't know why that's still there. In fact, why is that term even still there? So that was some old term for offset Z? Do not know. Probably some old code when we were doing things that we don't need to do anymore. Anyway, so yeah, point being, we've got that floor Z, and now we need to just find a way to get the floor Z. Everything else should work fine. The only thing that we need to do now is when we compute our raw XY, we just want to take whatever the Y value is and add to it some displacement based on the height off the floor. And again, this is a purely arbitrary personal artistic decision here about how much of an orthographic displacement we want for each bit of Z that you're off, okay? And so I don't know what that value is going to be. We're going to want to tune that value, right? We're basically going to have a value here which is like Y, ortho Y from Z kind of a thing. And we don't know what that's going to be, but we can just tweak it however we want to tweak it. So if we compile this, we should have no problems other than just we need a place to get the floor Z, and right now we don't know where to get the floor Z, right? I have no idea where to get that floor Z from. So when I do the object transform bit, I could just add it in there for now. So I could just say, well, we're going to need a floor Z here. If you don't specify a floor Z, then we can always just make the floor Z be 0, which would do no transforming at all. Now, what's interesting about that is that would also potentially let us get rid of some other aspects here, but we could probably make the orthographic stuff a little bit simpler if we wanted to. I'm going to ignore that for now. Point being, if we just add something to the object transform that says what the floor Z should be, then in theory I should be able to do something where I take the object transform, grab the floor Z out of it, and although we're not setting it yet, we should presumably be able to set that pretty easily because it's not a particularly complicated thing. So if I take a look at where we actually set these in terms of upright, I think it's here. You can see default upright transform and default flat transform. They don't set the floor Z at all, so it would just be set to 0. So if I actually do this now, in theory, I think we would get pretty much exactly what we had before. You can see that that's happening, where we have that ortho displacement, and that's all good, but we don't have we still don't have any scaling, right? Because the floor Z has just not been set by anybody. So let's go ahead and try to set that floor Z to something meaningful now, right? And all we need to do that is we just need some Z value for the floor, which we should know when we're actually putting these guys out, because we had to do stuff like break them up into layers to begin with. So if you take a look at what's going on here, you can see we're starting to compute that outside. This is back in the in where we're outputting entities, right? So where we're outputting entities is where this actually counts. We'll probably have to clean up some of the other code where these transforms are being set because they might need to set a floor Z as well. Like for example, when we're showing debug rectangles and stuff like that, those are going to have their floor Z set properly as well. But for the time being, we only really care about the entities because that's what pretty much all of our drawing goes through. So if we take a look here at what happens, we have this object transform. That's our entity transform. We're generating one of these default upright transforms for it. And, you know, that's interesting. Do we ever do a default flat transform? Wait a minute. When we draw, are we drawing all of our things as upright? That's just a total bug, right? We're supposed to be drawing the floors as flat. Hey, maybe don't send down 100% of the entities as flat. That would totally break our sorting. I'm not sure why our sorting is even working half as good as it is right now. I guess we give ourselves a pat on our back for having a sorter that's way better than it should be. Maybe I'm overreacting, maybe that's not what's going on there, but point being, that's a screw up. But that has nothing to do with what we're talking about right now, so that's fine. Anyway, point being, you can see us going ahead here and setting this offset P to being, this is the distance off the camera, so that's going to be the absolute Z displacement. So now the question is, where is the actual floor that this dude would have been on, right? And so you can see here where we've got entity Z layer, and we've got this sort of chunk Z situation going on here, which is saying like, okay, where is this guy in terms of floors? So we know what the relative layer is here. We just don't necessarily know what the actual Z value is for that layer. But we know that that is something that we had computed before. And the reason that we know that that is something that computed before, because you can kind of see in this thing right here, where we were doing like our fogging and all that sort of stuff, we already had to compute that, right? We had to compute the camera relative ground Z, because this is it right here, right? This is that value. So that's the value that we actually need to set for this guy. Unfortunately, we're not saving it anywhere, right? So we kind of need to have a thing here, which is like camera relative ground Z, and we kind of need to store that for everybody. And so that camera relative ground Z will keep the value that we actually wanted. So there's camera relative ground Z. And we just need to be able to set, when we set the fog amount, we just also need to be able to set what this is so that we can remember it now. And now we know where the camera relative ground Z is. And the camera relative ground Z is the thing that we have to look up here. What we should be able to do is just verify that this thing is actually inside the layers that we want. We've already done that, so that seems fine here. So all we should have to do is in the entity transform, when we get down to this point and we've verified that, we should be able to set the floor Z here to the cam relative ground Z value for our relative layer. So looking up into there, where's our fog amount? There it is. So our layer index it should have been computed somewhere. I don't actually know where it is. There it is. So we can just do that here. And I think that should be fine. Okay. So I think this should set the floor height, the floor Z properly now. So when we come up here, we should see that scaling happen, right? And you can see that scaling happen, which is nice. So you can see it seems to be working fairly correctly there when we kind of pop up here. That's all good. Of course, those guys are blocking me. I don't know why they're blocking me. That's not very nice of them. But now we do have the ability to sort of scale those two things up properly. Now, obviously, we sort of have a problem just with the way our levels are structured. There's nothing we're ever going to be able to do to make it render properly here because we sort of have these solid stairs coming up here. When I hop up here, if I have another stairwell on top of me, I'm not even going to be able to see myself. That's just kind of the way that would actually happen in real life. So we kind of have to work around that in terms of the art. There's nothing, the renderer isn't doing anything particularly stupid at that point. That's just how that's going to be. You know, and we could do other things like maybe alpha those out if we wanted to or something like that. But in general, right, we probably just don't want to structure our levels that way. We probably don't want to have two stairwells on top of each other, like put the other stairwell on the other side of the screen so that there's a bigger hole there and we can actually see up through it or something like that. But I believe that's really all we had to do to get our Z working properly there. And now we just have to deal with the artistic concerns of it, and off you go. Now, that's pretty much that entire to-do as far as the Z part of things is concerned. But we do have another sort of separate problem here, which is that I feel like, and I could be wrong, but I feel like, as I just added this right here, not flat, sorry, this is upright. I'm a little bit concerned that we never actually have any sprites that aren't being marked as upright, because we do default upright transform here, right? But then I don't know that we ever set it to anything other than an upright transform, which makes me concerned that all that stuff we did to handle both kinds of sorting, we're never actually taking any advantage of it, which means our sorts are all going to be kind of busted all the time, no matter what we do, I think. Again, maybe I'm misunderstanding something because, you know, hey, I have a day job, and I forget a lot of things about Handmade Hero while I'm actually working on other code for 8 hours a day. But that just kind of seems like what's going on, you know? And so I feel like these pieces here, when we're sort of doing these, this stuff, when we come through and do these pushes, I feel like these pushes that we're doing needed to be marked as flat, right? And because these, like for example, these right here, these entity transforms, these should all have been marked as flat. Okay, so we are, okay, we're fine. Because these are all below it, and we're only doing those for traversables. So all right, phew, okay, so that's fine. I was gonna say, what's going on here? I thought I was losing my mind, man. I thought I was losing my mind. Okay, so we're actually fine, I think, unless, because I feel like those are the things that we're actually rendering, right? Because here's the occupier tag that turns them to colors based on whether you're hopping on them, right? So it's all good. Okay. Whew. I got nervous there for a second. I was like, what's going on? But okay, so those are rendered outside, so it's all good. Everyone can relax, and by everyone I mean me, right? All right. So that seems pretty reasonable, and I don't think we have to really worry about that now. When we put the new art in, we'll see what happens. We'll try to construct some rooms that have some multi-layer stuff on them. But I think we're now probably pretty good in terms of like slight staggering. And you know what I could do is I could also just sort of I could sort of play with that value a little bit. Here, let me go ahead and scoot up to the part where we actually create rooms. And I think we had a thing in here where we kind of did a random sort of, like a sort of random variance of the height. And you can kind of see here, in fact, where we were doing this in terms of staggering things in X and Y. I'm going to enable like a little bit of a stagger in Z instead, and just to see what happens there. Just a little tiny bit of that. And I don't really remember what our convention is about where the floor is exactly, but yeah, so that's, you can kind of see what that looks like. It's pretty straightforward, and now we can kind of hop along some sort of uneven terrain, just make sure that that is working properly, and that looks fine. That looks like what I would have expected. So that's all good. I can hop up here. Here's another level of that, and off we go. So that seems correct. And it also seems like we do have a little bit of leeway there, so we can displace downward, and it doesn't get floored to the one below us. So I guess there's a little bit of a gutter in there, and so that should be fine. Now, we do have one thing that we might want to consider fixing a little bit. I think I'll probably let that wait, though, until the part where I actually care. But I think you can see that like the snapping that happens there. What happens is when we transition from one layer to another, we might want a kind of a zone where we blend between the two Z's that we would use. And so, try and explain what I mean here. And I think maybe by, I'm gonna tone this down quite a bit. I think maybe the right way to do it is to sort of construct a room where you can see this happening a little bit better. So what I want to do here is I'm going to try and construct a room that I guess the first thing I'll do is I'll just turn off the room that's one above us so we can see a little bit more easily. Let's go down to handmade.cpp. Oop, handmade.cpp. Actually, no, this would be world mode, wouldn't it? So add standard room. There we go. So instead of creating 4 screens stacked on top of each other, I'm just going to create one. And then when I only have one, if I come down here and hop upwards, right, like this, you can kind of see that when I get to the top, well, I guess I don't have anywhere to go. Right. Okay, that's not going to do it. I gotta at least add 2. I'll add 2, and when I add a standard room, I guess I'll say something about, is there a stairwell? So I'll only add the stairwell by like checking the screen index parity there. I'll only add stairwell on the first room, and I won't add it on the second room, right? So let's see. So what I want to do here is say, okay, that stairwell there. I think, let's see, I don't know what the difference between these two things are, to be honest with you. Is it just me, or do those look exactly the same? Is there any difference between those two things? I have no idea why we have 2 paths here, people. I think we were doing something here before and then we got rid of it. Anyway, so I believe this is the part, right, that creates a stairwell. So I'm going to say if add stairs. We'll do this. Otherwise, we're just not going to do it. So now, in theory, I should have a room above us, and that room should not have anything there. Yeah. Although, actually, I guess that's right. I also have to make sure that we don't do it. So, yeah, we would have to not put anything there as well. So I guess I want to do... If we don't add stairs, then I want to do like a... to skip is false. Or maybe add equals true. Add equals false. If add... Yeah. Man, I should just define a B32X. In fact, why don't I have a B32X? Does anyone know why we don't have one? Okay. All right, so now in theory there's a hole there, right? Yeah, there's the hole there. And so I'm going to make an even bigger hole so you can see it a little more clearly, what I'm talking about in terms of the problem. And then we can sort of talk about what we want to do to solve it. I think I don't have very much time left anyway, so we might leave it for tomorrow, but I just want to put it in, I want to put in the stuff so that we can see very clearly what the problem is that I was kind of talking about. Okay, so yeah. What I want to do here, I think, is say if offset equals 3, or, you know, we're not adding stairs, and offset x equals 4. So we kind of have a bigger, oops. So we kind of have a bigger region to look into. And I think I might actually want it to be 1 over the other direction now that I think about it in terms of what would be easier to see, because it's not quite what I was hoping for. Let's say equals 2. And maybe we'll also say here, and the offset is greater than or equal to -2. I'm going to say the same thing here with offset or add stairs and offset less than or equal to 3. I'm going to see if how that treats me. And let's see. So I hop up the stairs, and there you can kind of see we've got a nice big jump leeway. So do you see how when I cross that boundary and my dude hops down, right? It's hard to kind of get him to hop down because it's a sort of a big way. But when I make that jump, the transform is discontinuous. So I just pop, right? And like I pop scaling immediately, right? Which is not probably what we want. So, and even though this is like an exaggerated case, it's just going to be bad, right? You can see once the art is kind of cleaned up in there, you're going to really see that pop, and it's not going to be fun. So the question is, what can we do about that particular situation? And I think what we probably want to do there is maybe just make that scaling be like a little bit cleaner, just give it a little bit more room. And that's not particularly hard to do, right? We can, if we want to, just say, well, okay. So you can see what we're doing in terms of the floor Z here. Here it is. What we could do is say, well, if we know what the floor height in general is, then it shouldn't be particularly difficult for us to just take a little bit of that range. I think I talked about this before, but to just take a little bit of that range and do sort of some interpolation there. So for example, if here's the way that we've been doing it, where it's like, okay, here's the location of the dude, and so we have sort of our floor Z is here, right? And this is our height, and this would be the next floor up. What we can do instead is introduce a zone in which we transition between the two and do a smoother scaling of the entities in that band, right? And so how we would do that is just say, well, if the H is within within this bound, whatever that is, then we don't care. But if the H is above that bound, then we use we map this range to 0 to 1 essentially, and we lerp between the floor Z and the next floor Z up from what it is before we do the transform, right? So essentially when we do our transform here, when we take our floor Z that we're going to use for the actual projection, right? What we want to do there is just linear interpolate this, right? So we want to kind of say lerp between the floor Z and floor height, that kind of thing. So basically we would have two things we'd go between, the floor Z and the next floor Z up. And what we would want to do is base that on where the PZ was relative to the floor Z, which means we do actually then want to compute this a priori, right? So we do want to be able to say, okay, let's figure that out. And right, when we do that computation, we'll know. However, we kind of do need to know, I suppose, since we're lerping it, we want to do this subtraction afterwards with the real floor Z so that that's continuous as well. So really we want this to be some other thing, which is like, our test Z, where we compute what the floor Z is relative to the point, the Z point, right? So we kind of know, like, okay, here's where we are. And now we just have to see whether that thing is roughly in the range of this floor height here, right? And we've got to see what that is. So we need some kind of an apron there, and we just want to know, I suppose, is, clamp. I guess really all we want to do is say clamp 0 to 1 map to range, right? I think that's our sort of all-purpose function for this. Right? So this allows us to do a min, a max, and a t. So what I think we can do here is say that, our t value, our floor t value in this case, in fact, I guess I don't need to show the test z there. I could just say that, this is the value that we have. We know that we want to lerp it in a sense. I guess we could say next floor z. This is that next floor up, right? And so what we want to do is say, well, okay, we know the high end of the range, that's the next floor z, but we don't want to use the actual floor z as the base of the range, because the whole point of this is just to use like a narrow band. So essentially we'd just be using like the next floor z minus the apron value, right? Whatever that apron value is. And we could make that be parametric potentially if we want to in the future. For now, let's just say we set it to like 0.1 or something like that, right? And then all we'd really need to do, I don't know what I called this function. Did I just call it lerp? Yeah. And so when I do this object transform now, I just need one other thing, which is the floor height. Now I could do floor z and the next floor z. I suppose I could do it that way, since those are the two things we actually want. Maybe since we don't actually ever use the floor height natively, maybe we just do that, because then it's a little bit more direct, I suppose, right? That definitely looks better. All right, so let's call it that. When we compile now, that value is not getting set, which is not going to be good. So we need to kind of go into our entity output again and actually make sure that we do specify what these actually are. Now this is a pretty easy thing to specify. All we have to do is take whatever the floor z was before and just add to it whatever the height of the floor actually is. And the height of the floor should be just in here because we're sort of doing that computation, the typical floor height thing. And so the renderer would actually be supporting, non-uniform floor heights. We're not really we're not supporting that here in the entity output, but maybe that's something we'll change later. So I don't want to force the renderer to have to do that for no reason. All right, so now when I kind of come up here, I don't know if that's whoa, that did not. Well, I suppose that is sort of lerping there, but that is not really giving me a very satisfying result. Let me see about increasing that apron just so I can see. I want to see about this here. I want to see that happen a little slower. Okay. I wish these familiars would go away. They're real annoying. Okay. So, yeah. That is not great. Not a fan of that. And I'm not sure exactly what to make of it. Because I don't know any other real way we would be able to deal with that. We could obviously turn off the scaling entirely and just leave it so that it doesn't do that, so it doesn't ever do the sort of sizing stuff. The sizing stuff looks pretty cool. But I don't know. That looks unconvincing. Maybe there's something fancier we can do there. Maybe there isn't. But yeah. I mean, it might be that the Y displacement is really the only thing that we're going to be able to do. I'm not sure. If we wanted to do that, you know, we could take all of this stuff, obviously, that's happening here and just say, okay, the floor Z we never actually use, right? And that would look like this. And then we just sort of have this, we're back to the standard situation of, you know, that all works. It's just a lot more boring. It doesn't have that nice feel that the perspective version does. You know, it still like fades out and everything, but it just doesn't have that same kind of feel to it. So I don't know what to do about that. I don't know. I mean, we're going to have to keep that apron pretty narrow if we don't want a bunch of objects sliding around all the time on it, you know? And, oops. But yeah, I just don't know how we would keep that from getting out of hand. Let me think, is there any other thing I could do besides the lerping? Yeah, I don't know. Because it is a fundamentally kind of nasty problem. I mean, you got this thing that's... Well... I guess maybe you could say that if you were to keep some range in which the scaling didn't occur, maybe that would help. I don't know. Make sure I'm doing this right, first of all. So assuming that you're close to the top of the range between the floors, yeah, you're just looking at the apron, then you lerp between the two floor Z's in terms of what your transform is. That's probably pretty good. I mean, I don't know that there's much else I would do to that. Yeah. So I don't know about that. I don't know. And here's the version that looks, I think, it looks like what we want. Oops. Because I was feeling pretty good about this. It's just, it's got that popping artifact, right? Because otherwise, it's what I wanted, right? That looks exactly like what I wanted. The problem is, like, I just don't know how to deal with the popping part in terms of the transform. You know, and maybe there'd be a solution just for the hero, because the hero is always kind of where the camera is. But, you know, I'm thinking about other entities as well, and they would kind of have these problems, I think, where, you know, as you kind of saw them go up and down. I'm going to get rid of that jitter on the floor as well for the moment while we're looking at things, because it's kind of distracting. So I'm going to go ahead and just take that out of the equation as well. But yeah, so... I don't know. I guess we'll leave this till tomorrow. We'll talk about it some more. But I'm worried about that. I don't know of an immediate solution. Because yeah, that looks like what I want in all other respects. But I just don't know how to solve that popping problem of moving between. Because now you essentially got two spaces in terms of the transform. I don't know how to really get. I don't really know how to get away from that. You know. I don't know what I could do to make that not cause us problems. So yeah, that's not great. Maybe we'll think of something though. You know, maybe we'll think of something. You don't want to give up right away. I'm going to go ahead and go to the Q and the A, since it is Q and A time. Looks like going to be an easy night. No questions. Ask me no more questions, I'll tell you no more lies. I don't know the rest of that song, but I know it's like a nursery rhyme sort of thing. Cyberpunk Hobo. Are there any particular reasons not to prefer continuous scaling in Z besides easy sorting? Yeah, I'm like... I just don't feel like the art looks good with that kind of scaling, because so it's not obvious to see because we haven't tried to drop in the real art yet, but essentially you got this problem of, you know, here's what a room looks like, let's say. Right? So that's the top wall, and then here's the ground or whatever, something like that, right? And the problem with it is, if you do that scaling, then now you need to have some way of doing artwork for like these sides and stuff like that. And suddenly you pretty much have to just do 3D at that point, right? Whereas if you're orthographic, you know, no matter where something is, it still just looks like this. So you can just have one sprite for that and one sprite for the top and be done, right? Because it doesn't matter where on the screen it always is the same artwork, right? And so basically, to avoid going to full 3D modeling for the scenes, you pretty much don't ever want there to be any perspective transform on the actual stuff, on the actual scenery. Now, you could perspective transform the people somehow, but they have to line up with the scenery, and so you can't really transform them completely willy-nilly, right? You still have to have some conceptualization of what's going to happen. And so I don't really know how to make that kind of trade-off, right? Again, I'm not really a 2D game programmer. I'm more of a 3D game programmer, so it's kind of not, it's not my area of expertise, like how to do like whatever the hacks are that you might want to do to make this sort of thing work more logistically. It's kind of a, you know, I'm sure it's a black art, right? Like, it's like, hey, if you've done tons of 2D games, you probably have a lot of tricks up your sleeve for like, well, this is how I do covering this part of it or whatever. So, you know, that's really all that is. So I don't really have anything against the perspective scaling. It's more just that, like, artwork-wise in 2D, it doesn't really super work. You know, you can do other things. You could make little blocks and texture them. You know, you could sort of make it pseudo 3D there, and then you'd be fine. Or you can do a number of things like that. But I don't really want to go down those roads. I want Handmade Hero to just be using straight bitmap art. That's kind of, you know, one of the limitations that I was sort of saying it should have. And so at that point, I don't know that there's really that much you can do. So yeah. So it's an issue. I'm not sure what to do about that issue. So I saw the kid asked, I may have missed it, but what's the reasoning for type defing a B32X as a B32 and not just use B32? It's the same reason I tend to have like S32X and U32X. It's like, if I don't care what size the thing is, I'll use the X, so that, like, you know, if for some reason there was a platform where it's more efficient to use 64 bits to store the Boolean, because like operating on 32-bit registers has a cost because it's like 64-bit native and doesn't like to downshift or something, then it can. That used to be a lot more relevant. It's sort of a force of habit. It's not super relevant now. Like, I don't know that the x64 architecture cares at all whether you operate on a 64 or 32, 16, or an 8. I don't know. I don't know about ARM, but generally speaking, there definitely have been, like, I feel like there were definitely times in the past where there have been architecture revisions where you end up in a situation where if you force the processor to downshift, it gets unhappy, right? So if you force the processor to do an operation of some kind on a 16-bit value instead of a 32-bit value and it's 32-bit native, it gets upset and it goes slower, right? So I don't actually know that we need to do this for any particular reason, but my habit tends to be to type X at the end of things, and so really most of all that type def is to make it so that I don't have to think about it anymore. I can just type the X if I want it, and not if I don't. So that's really all it is, and it's the same for all the types. That's just what the X means in general. The X is just, I'm telling you that I'm using 32-bit computing here, but I don't care if you go up to 64-bit on me. It wouldn't bother me, right? And technically, in a lot of those places, I could probably have called it a B8X in a fair number of them, but, you know. Really, I think part of the problem is just C is not particularly great at expressing things in size invariant ways. Like a lot of equations, you want to just specify and say, you know, look, however many bits you needed this to be for this to work out is how many bits the thing should be, or whatever. You know, it doesn't have a lot of that, unfortunately. Let's see. The Sizik thought. Have the floor above transform with the widest placement respective to the current floor until you jump over to it, at which point the view cuts to be relative to the new current floor. Have the floor above transform with the widest placement respective to the current floor until you jump over to it, at which point the view cuts to the relative. I don't think I understand what you're saying. I don't think I followed that one. Demitsuki, I just watched your papers talk and I didn't get the Minkowski sum exactly. I don't get where you deduce the points to subtract from each other. That may require a more elaborate answer. Do you want to maybe ask that first thing on tomorrow's pre-stream, and I could walk you through it? I'm not sure exactly what you're talking about, but I have a guess. But either way, I could walk through the portion of it that would probably explain that in a little more detail. The Papers We Love talk obviously was not supposed to be a complete explanation of GJK because it was packed into like something like 15 minutes or something like that. So, you know, yeah, it's a little bit fast. But do you explain it on stream before so I can go to the archives? You can, if you're looking for like the original one where I talk about this, you can, in fact, it's on the first page of Google. If you just go to GJK, this right here, this video from long time ago, you can actually watch, and it kind of should walk you through it maybe a little bit better. I don't know. But if you want to watch that one, it might answer your question, but it might not. Sinocron. For the stairs, have you considered stairs on a particular floor go down instead of up? Then you wouldn't have to worry about alpha. I'm not sure that I understand what the difference would be there. Like, upstairs are stairs. They don't go down or up. They're just stairs, right? And you traverse. It's whichever way the player traverses them that determines whether they're going upstairs or downstairs, right? Yeah, an amusing anecdote from the Papers We Love conference is they were like, they said it's gonna be oh well, I'll tell that anecdote later then. The Sizik question. So instead of the above floor perspective transforming into place you move the stairs, it stays still and jump cuts to the top perspective once you hop to a tile on the floor. Well, yeah, but the problem is in that case, then I would just turn off the perspective altogether, right? The whole point of this is to have that perspective transform because it looks cool, right? So that's what I'm trying to get. If I wasn't trying to get that, I could just turn it off entirely, right? So I'm trying to figure out a way to kind of have my cake and eat it too, which might not be possible, but I'm just trying to figure out a way that I can get that nice look of the perspective floor coming into place, but without having a discontinuity or a weird motion that looks really strange. And I don't know, that might just be a complete fool's errand. It might be that that's not possible at all. You know? Anyway, so the anecdote from the conference was like they were like, oh, you know, we're gonna have someone doing live captioning for it, so you know, there you go. And I'm like that's not gonna work for my talk. I'm like, there's no way they're gonna be able to type captions at the rate I talk. And they're like, no, they're really good. And I'm like, oh, okay. And then after the talk, it was like, nope, they totally couldn't keep up. And the person who was doing the captioning came up to me and was saying like, well, you know, I was keeping up with you up to about 330 words per minute, and then I had to like just kind of skip most of it. And I was like, yeah, I tried to tell them that, but they didn't listen to me. Sorry, like, because you know, you can't type that fast. No one can type that fast. I certainly can't, and you know, stenographers are better than me and they're using shorthand, but still, they're not that much faster. 330 words per minute. I mean, my God, no one can type that fast. William Bundy, are you doing a whole layer transform at once or per object? We actually have per object transforms. So, you know, we can do whatever we want. I just can't think of what we would do that would work real well, so I don't know. Sinocron, yes, but currently stairs are owned by the floor below them. That's true. If they were owned by the floor above them, then you wouldn't see the stairs 2 floors above, since they would be 2 floors above, thus not blocking your way and not needing alpha. Oh, I see what you're saying. You're talking about from the thing I said before where I don't want to have them kind of on top of you. That's true, but then you also wouldn't really be able to see to get on them in the first place. Right? Did Buckminster Fuller speak particularly fast, pseudonym? I have never heard him speak. I suppose maybe there was like a video of him. Did anyone record that? It would have been a long time ago, but probably someone did, maybe, or an audio recording, I suppose is all we would need, not a video. All right. I'm going to go ahead and close it down. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can play around with it on your own machine. We also have a forum site if you want to ask questions, a Patreon page if you want to support the video series, a schedule bot which tells you when we're going to be live, and an episode guide for catching up on old parts of the series. I will be back here tomorrow night, 8 p.m. again. Same time, same place. Hope to see you there when we will consider this problem a little bit more and decide if there's anything we can do to save our nice little perspective transform, which I think is kind of cool looking, and so I was kind of hoping that we could. Maybe we can't, but we'll at least try. Okay, so that's about it for now. I will see you guys tomorrow. Until then, have fun programming, and I'll see you on the internet. Take it easy.